Hello there guys, welcome back to another epic inexorable maths video. In this video we have an integral right here, the integral from 0 to pi over 2 of the square root of sine x plus 1. Looks like a pretty normal integral, right? It is quite normal, but the way that we can solve it is really cool, I think. It's going to use a lot of things. We're going to use two different trig identities, okay? And it's just a really cool integral. So, maybe the most obvious thing to do would be to let u equal sine x plus 1, maybe. But I'm going to show you a cooler way because that does work as far as I'm aware. I have not tried it, but I don't see why it wouldn't work. We have a cooler way. All right, and so let me show you. So let's rewrite this. So we have the integral from 0 to pi over 2 of the square root of sine x plus 1. Now guys, what I'm going to do is, again, this is not obvious, but it's just so cool. What I'm going to do is I'm going to use the double angle formula on sine x, okay? And this is how I'm going to do it, okay? I'm going to say that sine x is 2 times sine x over 2 times cos x over 2. Hopefully you can see that and it's not being cut off, but it's the double angle formula for sine, but instead of using sine 2x, I'm just going to use sine x. And you'll see why in a second, okay? Because I know that seems random, but you'll see why. So sine x, we can replace it with 2 sine x over 2 cos x over 2. And then there's still a plus 1 there. Okay. All right, now you might say it looks like you've made it worse, but guys, let me just bring it home, okay? So the integral from 0 to pi over 2 of the square root of, and then what I'm going to do, that was the first trig identity. The second trig identity is I'm going to replace the number 1 with sine of x over 2 squared plus cos of x over 2 squared, okay? So we also have an identity that says that cos squared of technically whatever you want plus sine squared of the same thing is always equal to the number 1. So I'm going to replace the number 1 with cos squared x over 2 plus sine squared x over 2. So overall, I have the integral of the square root of 2 sine x over 2 cos x over 2 plus cos squared plus sine squared. And I'm using x over 2 here. I'm hoping that this isn't cutting off what I'm writing. That would be very bad. Okay. So you might say, oh, that looks really bad. What have you done? What have you done? It was looking pretty nice and now it's looking pretty bad. But this is the punchline, okay, guys? What is inside of that square root? Well, a bunch of trig, right? Cos squared plus 2 sine x cos x plus sine squared. Stay with me. Do you agree or disagree that I can write the inside of that square root as cos x over 2 plus sine x over 2, all in brackets, squared. And then that's still inside the square root, so I have to square root it. But look at that and let me know, because if we expand this out, cos x over 2 plus sine x over 2 squared, well, you get cos squared, there's a cos squared there, plus sine squared, there's a sine squared there, plus 2 sine x cos x, or sine x over 2 cos x over 2. Tell me if that makes sense. Yes, and that is the cool bit, because we have the square root of something squared. We used an identity, two identities, to turn it into a perfect square, and that's pretty cool. And so we can replace, we're squaring something, we're square rooting it. Now technically, guys, we have to be a bit careful because technically, if you square something and square root it, you don't necessarily get the same thing back, you get the absolute value back, because if the original thing is negative, you square it, you square root it, it makes it positive. So technically it's the absolute value of cos x over 2 plus sine x over 2, but they have, everything's cancelled out, and this is pretty nice. Now you might say, oh no, how do we deal with the absolute value? In this case, because the limits are only 0 and pi over 2, well, cos of x over 2 and sine of x over 2 are both positive everywhere between 0 and pi over 2, and including 0 and pi over 2. So we really can ignore, because everything is positive here, so we can ignore the absolute value signs in this case. If this was an indefinite integral, it would be much more complicated because it can be positive or negative in different places. Okay, and then we just integrate this. So maybe I will come up here just to save me from crouching down. And this is a pretty simple integral, right? So what does cos integrate to? It integrates to sine, but it's an x over 2. So this is going to become 2 sine x over 2. That's what cos x over 2 integrates to. And then sine x over 2 integrates to minus 2 cos x over 2, okay? Because of the reverse chain rule, or the normal chain rule, if I differentiate 2 sine x over 2, the sine becomes a cos, but the x over 2, the derivative of x over 2 is 1 over 2, 1 over 2 cancels out with 2, and same logic applies for the other one. The limits of integration are 0 and pi over 2, like that, and we plug in. So we have 2 sine pi over 2 divided by 2 is pi over 4, minus 2 cos pi over 4, that's in brackets, minus, and then we plug 0 in, but we have 2 sine of 0 is 0, so I'm just going to write 0, minus 2 cos of 0 over 2, so 2 cos of 0 is 1, so minus 2 there. All right. Sine of pi over 4 is actually the same number as cos of pi over 4. They're both root 2 over 2. So 2 times root 2 over 2, that's root 2, minus 2 times root 2 over 2, so minus root 2, minus minus 2, that's plus 2. The root 2's cancel, 2 is the answer. So the answer is 2. So this integral is equal to 2. And that's it. So this is a really, really cool question in my opinion. Again, it's not necessarily the only way to do it. It's definitely not the most obvious way of doing it. But come on, can you deny that's a pretty cool question? I can't lie, right? It's very cool. 2 different trig identities, perfect square, amazing. It just is a very, very good question. Anyways, guys, thank you so much for watching as always, and I will see you in the next video. Cheers.